The history of the Bohr Model.
Bang bang.
Professor Ernest Rutherford.
Good morning.
So today I'm gonna discuss about the atomic theory and my planetary model. And that is how I conclude my planetary model in the atomic theory. Are there any questions? Violent interactions? Yes, Mr.
Niels Bohr.
What is your query, sir?
Sir, I think there's something wrong with your model.
Well, let's talk after class. Class. Now, what were you telling me a while ago, Mr. Bohr?
Sir, I think it's incomplete.
Well, in what I think, I believe that there's a positive nucleus contained in most of the mass of an atom. The rest is just empty space. I made an experiment before. I conducted a gold foil experiment during class. And it proved that most of the atoms is made up of empty space. What do you think, sir?
How about we experiment and study about this, sir?
Let us. I will be your mentor. Let us go to the library.
You see, I believe that atoms contain orbits with electrons that travel in a circular motion.
But how should it look like?
It should be like this.
I agree. That makes so much sense. We should go and tell all the scientists.
It's a great idea. The atom should contain electrons orbiting the nucleus.
That is superb and excellent. We should tell the world.
The Bohr model is a planetary model in which the negatively charged electrons orbit a small, positively charged nucleus similar to the planets orbiting the sun, just like the solar system as they mentioned, except the orbits are not planar.
The Bohr model has an atom consisting of small, positively charged nucleus orbited by negatively charged electrons.
Radiation is absorbed or emitted when an electron moves from one orbit to
The energy of the orbit is related to its size. The lowest energy is found in the smallest orbit.
This tutorial is designed to help you better understand Bohr's model for the atom. According to this model, there are two major parts of the atom. We have a nucleus and we have electrons which orbit the nucleus. Inside the nucleus we have protons, which are positively charged, and neutrons, which have no charge. Electrons, which are negatively charged, orbit the nucleus. So in order to use this model, we need to also use the periodic table. Let's take a look at lithium. It's atomic number 3. That little 3 in the top of the box tells us how many protons are in lithium. We know protons live in the nucleus, so we're going to put 1, 2, 3 protons in, making this a lithium atom. But there are more things that belong in the nucleus. We need to look at the mass number, or atomic mass, in the bottom of the box. According to the periodic table, the mass of lithium is 7. If we already have 3 particles in the nucleus and the periodic table says we need 7, then those extra 4 particles are neutrons. So 1, 2, 3, 4. All atoms as they appear on the periodic table are neutral. So we need to have a balance between our positively charged protons and our negatively charged electrons. So if we have 3 protons, we're going to need 3 electrons. But according to Bohr's model, those electrons don't all just hang out in the same place. They have a nice specific arrangement. There are energy levels in which they can reside. The closest energy level is called the K shell, and it can hold up to 2 electrons. The next one out is the L shell. It can hold 8. Then we have the M shell, which can hold 18. There are more shells, but we will not discuss those at this time. So let's put our electrons in their appropriate place. We're going to put 1, 2 electrons here, but we still need one more. There's no more room on the K shell, so we have to move out to the L shell. Here we have a nice neutral atom of lithium. Let's try another one. Let's try oxygen. Oxygen's atomic number is 8, which means it has 8 protons. 1, 2, 3, 4, 5, 6, 7, and 8. Its atomic mass is 16. That means it has 16 particles in its nucleus. Since 8 of those particles are protons, the other 8 must be neutrons. 1, 2, 3, 4, 5, 6, 7, and 8. Now that we have our nucleus built, we must surround it with our electrons. Since there are 8 protons, which are positively charged, we need 8 electrons, which are negatively charged. The first 2 electrons fit nicely on the K shell, but now we need to move out to the L shell to put the other 6. 1, 2, 3, 4, 5, and 6. Now we have a nice neutral atom of oxygen.
So now, I'm going to be making an example of a simple Bohr model. The numbers you need to remember are the numbers 2, 8, and 8. Add up to 18. This is the nucleus. It's the centermost part of the atom, and that's where the protons and neutrons are found. This is the innermost circle, which has 2 electrons. The middle part of the circle, it's 8 electrons. In the outermost part, so for example, we want to make a Bohr model of neon. It's neon. It's the 10th element, and in its nucleus, 10 protons, 10 neutrons. So always remember the 288. So the innermost 2 electrons, and in the middle there are 8, always 10. Always work inside out, and that is the simple way of making a Bohr model.